One of the most mesmerizing cosmic events in the making is a potential supernova of Betelgeuse, a massive crimson-red supergiant located at the well-known shoulder of the Orion constellation. Betelgeuse, nearing the end of its stellar life, stunned astronomers in 2019 when it suddenly began to dim, an effect visible even to the unaided eye. Over several months, its brightness decreased so dramatically that many observers speculated the star was on the verge of dying. When astronomers turned their telescopes toward the star, they found compelling evidence of substantial dimming. Scientists now believe Betelgeuse may be preparing to explode in a supernova, a powerful event that would mark the end of its life. But exactly when and why this cosmic blast will occur remains a mystery. Could it have catastrophic consequences for Earth? Betelgeuse, also known by its formal name Alpha Orionis, sits at the top right shoulder of Orion the Hunter. While it's the second brightest star in the Orion constellation, just behind the blue-white supergiant Rigel, it captures attention due to its immense size, deep red color, and fluctuating behavior. Despite alpha stars typically being the brightest in their constellations, Betelgeuse continues to fascinate astronomers. As the 10th brightest star in the night sky, and the 7th most visible from regions like North America, Europe, and Canada, Betelgeuse holds a unique place in celestial lore. Its name comes from Arabic, meaning the armpit of the giant, referring to its position in Orion. The star loses around one solar mass every 10,000 years, shedding material in all directions and forming a surrounding nebula that spans 30 astronomical units, 30 times the distance between Earth and the Sun, and is 250 times more massive than the star itself. At its core, Betelgeuse fuses hydrogen nuclei under immense pressure into helium, generating heat and radiation. Once its hydrogen supply runs low, the star begins to fuse helium and carbon instead. When helium is exhausted, neon and carbon fuse into iron. But unlike previous fusion stages, iron doesn't generate energy. This causes the star to collapse under its own gravity, ultimately triggering a spectacular supernova, one of the most powerful explosions in the universe. Stars emit different wavelengths of light, depending on their age and stage of evolution, ranging from the brilliant blue of youthful stars to the red hues of aging giants. Ancient astronomer John Herschel once described Betelgeuse's color as ruddy, while early Chinese records noted it appeared yellow, suggesting it might have once been a yellow supergiant. Massive stars like Betelgeuse burn through their fuel at an accelerated rate, resulting in relatively short lifespans. Though our sun still has over 5 billion years left, Betelgeuse is rapidly approaching its end, potentially exploding as a supernova in the near cosmic future. However, the exact timing remains uncertain. Betelgeuse undergoes 2 known cycles of brightness variation, one every 5 years, lasting around 100 days. These cycles are believed to be caused by the expansion and contraction of the star's outer layers, affecting its diameter and surface temperature. Interest in Betelgeuse soared in 2019 to 2020, when it dimmed unusually and then briefly brightened again, prompting speculation that it might be nearing its final transformation. While Betelgeuse has been studied since at least the 1st century BC, the true cause of its dimming episodes remains elusive. Interestingly, the star is also moving through space at approximately 30 kilometers per second after being ejected from its birthplace in the Orion OB1 Association, the same stellar nursery that produced Orion's belt stars. This high-speed journey has created a bow shock that stretches over 4 light years. Accurately measuring the size and distance of red supergiants like Betelgeuse is notoriously difficult in astrophysics, with many variables complicating diameter estimates. Adding to the challenge is the star's status as a pulsating variable, constantly changing in size and brightness. Betelgeuse's size isn't constant, it fluctuates over time. This, combined with the dimming of its outer layers, causes its brightness and color to shift as we observe it from different angles. Moreover, the material expelled by the star significantly influences how its light is emitted and absorbed, altering our perception of its brilliance. Observing Betelgeuse directly is also complex because its apparent size varies depending on the wavelength of light being used. In fact, measurements can differ by as much as 35% across the light spectrum. In July 2009, the European Southern Observatory released images from its ground-based Very Large Telescope, VLT, interferometer, revealing an enormous plume of gas extending up to 30 astronomical units from the star, roughly the distance between the Sun and Neptune. This was just one of at least 6 massive outflows observed from Betelgeuse. These expulsions offer valuable insights into how massive stars lose material in their final life stages, a process that may play a critical role in their eventual collapse. Yet, the mechanisms at work in Betelgeuse's vast upper atmosphere remain largely mysterious, including how red supergiants like it shed so much mass. These stars are crucial to galactic chemical enrichment, and thanks to advances in interferometry, astronomers are making strides toward understanding these complex processes. In 2019, scientists using the Hubble Space Telescope and other instruments discovered that Betelgeuse had expelled a substantial portion of its outer shell, triggering a massive surface mass ejection, SME. While the Sun produces solar mass ejections, Betelgeuse's eruption was thousands of times more powerful, releasing material estimated to be 400 billion times the mass of a typical solar event. This massive ejection explains the star's dramatic drop in brightness in late 2019. By mid-February 2020, Betelgeuse had dimmed to about one-third of its usual brightness, declining from a magnitude of 0.5 to 1.7. However, by February 17th, the dimming had plateaued, and by February 5th, it appeared to have halted altogether. Importantly, the observed decrease in visible light wasn't due to a core collapse, as no significant changes were detected in infrared emissions as of February 24th, 2020. If you enjoyed this video, feel free to like, comment, and subscribe to stay updated on future content like this. When Betelgeuse eventually explodes as a supernova, it will rank among the most spectacular celestial events ever observed. Despite being 640 light-years away, the explosion will shine so brightly that it could outshine the full moon and remain visible even during the day for weeks or months. Experts predict the supernova will release more energy in just a few seconds than our Sun will emit in its entire 10-billion-year lifetime. The resulting burst of light will travel across the cosmos and appear as an incredibly bright point in our sky, unlike anything we've seen before. Rest assured, though, despite its intensity, the supernova will pose no threat to Earth. Betelgeuse is far enough away that its explosion won't endanger our planet or its biosphere. What it will offer, however, is a once-in-a-lifetime scientific opportunity. In recent years, Betelgeuse has returned to its normal brightness, but its erratic dimming continues to be closely studied. Scientists are employing advanced tools like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based arrays, such as the VLT and ALMA. These instruments are monitoring fluctuations in surface brightness, convective activity, and ongoing mass ejections, phenomena that reflect the star's underlying instability. One widely accepted theory attributes a dramatic 2019 dimming to a vast cloud of stellar dust produced during an eruption, which temporarily obscured the star's light from our perspective. Understanding Betelgeuse's behavior is key to unlocking the life cycles of massive stars, particularly those on the verge of supernova. These insights not only help predict similar events in distant galaxies, but also explain how chemical elements are distributed across the universe. The cosmos holds countless wonders, and among them is a dramatic formation and dispersal of elements like iron and gold across space. At the heart of this process stands Betelgeuse, a cosmic ticking time bomb slowly nearing the end of its life. Whether it explodes tomorrow, next year, or 100,000 years from now, when it does, it will offer a galactic spectacle and an unprecedented opportunity for scientific discovery. Studying the life and death of stars like Betelgeuse goes far beyond academic interest. It is essential to understanding the very fabric of the universe. Massive stars act as cosmic forges, creating heavy elements in their cores. When they die in supernova explosions, these elements are scattered into the surrounding space, enriching interstellar clouds of the raw materials needed to form new stars, planets, and even life itself. Betelgeuse's anticipated supernova would be a rare gift for astronomers. Most supernovae observed in modern times occur in faraway galaxies, limiting the detail and data scientists can extract. But Betelgeuse, located in our own Milky Way and relatively close in astronomical terms, presents a unique chance to observe every phase of the explosion and its aftermath with unparalleled clarity. What makes this potential event even more exciting is its relevance to the study of neutrinos and gravitational waves. When a massive star collapses, It emits not only visible light, but also floods of neutrinos and potentially detectable ripples in space-time. Instruments like LIGO, Virgo, and IceCube could capture this data, providing fresh insights into both stellar collapse and the fundamental forces of the universe. Astronomers are also closely monitoring Betelgeuse to gain a deeper understanding of red supergiants, one of the most mysterious and least understood stages of stellar evolution. These colossal, unstable stars are notoriously difficult to model, but with advancements in space telescopes and high-resolution spectroscopy, scientists are making progress. Betelgeuse may help answer some of the biggest questions that remain. For now, Betelgeuse continues to pulse, flicker, and intrigue. While its brightness appears steady, scientists remain vigilant, prepared to document every fluctuation should a supernova occur. The data gathered could transform our knowledge of stellar life cycles. Until that day, whether tomorrow or millennia from now, Betelgeuse will remain a luminous sentinel in our sky and a symbol of cosmic mystery, captivating astronomers and stargazers alike as both a celestial marvel and a countdown to one of the universe's most spectacular events.